Welcome to the second video on CVP. We continue looking at the charts that you'll be tested on. We're looking at the profit volume chart. So in this lecture example, we are given a sketch of the profit volume chart from our earlier example 1. You are required to label the letter Z. So what does the letter Z represent? You've got option answers there, you've got break-even point, you've got fixed costs, you've got profit, you've got contribution. So you're being asked about this line here. So that is our contribution. Remember this is our fixed cost line, which starts at the fixed cost of 5,700. We have our break-even point. Our break-even point will be at this point where the units we have sold, we are recovering our fixed costs. We are not making a profit. That's our break-even point. So from this point going this way, you have your margin of safety. So you've got your margin of safety there. So Z represents the contribution. We have another lecture example question. Indicate the following points on the chart in lecture 3. The break-even point, we already seen the break-even point as being that one there. The fixed costs, we also have the fixed costs there. The margin of safety, we also identify the margin of safety as being this point here. How would the line differ if the fixed costs increase to $6,500? Currently our fixed costs are here, so 6,500 should be somewhere on the bottom, towards the bottom of this line. So if the fixed costs are there, it means that our break-even point should change, because now our fixed cost will be 6,500 divided by our unit contribution of 1.5. So the units required to break even will now be 4,333. However, the gradient of the line will not change. Next, describe the impact on the break-even point if the selling price increased to $10. So if the selling price increased to $10, so it means our contribution will change. Earlier our contribution per unit was 1.5. So our contribution per unit now will be 3.50. So the break-even point, units required to be sold, should reduce from 3,800 to 1,629 units. So meaning we'll reach our break-even point quicker. We now look at multi-product break-even analysis. The formulas for break-even point changes slightly when it comes to multi-product break-even analysis. So the formula changes to fixed costs divided by the weighted average unit contribution. The break-even revenue formula also changes to fixed costs divided by the weighted average CS ratio. We'll apply this in the next question on United Trading, which sells 3 products. So it sells footballs, baseballs, and rugby balls. We're given the selling prices there as 7, 6, and 9 respectively, and the variable cost as 3, 4.5, and 5 respectively. Then we're given the budgeted sales, 2,000, 4,000, 3,000. Assume that the sales mix is fixed in these proportions. Fixed costs are given as 20,000. You're required to compute the break-even sales volume. So we only have one fixed costs. We need the unit contribution, but we've got 3 products, so we have to compute the contribution for each one. But because the contributions differ with the units, the sales units are different, so the contribution for each one should be multiplied by the sales units. So the contribution for the football will be 7 minus 3 equals 4. Baseball 6 minus 1.5 equals 6 minus 4.5 equals 1.5. And the rugby 9 minus 5 equals 4. Then these contributions, we multiply them by the units. Once we multiply them by the units, then we divide by the total units to give us the average contribution of $2.889. We now have the average contribution, so we can divide the fixed costs into the average contribution to give us the break-even units total of 6,923 units required of the combination of the balls, baseballs, and rugby for us to break even. Next, we want the break-even number of units for each, because what we have got, the 6,923 is the total, but we want for the individual products, so we prorata those depending on the quantities. So our total sales mix, we had 2,000 footballs, 4,000 baseballs, 3,000 rugby balls. Which are these ones here. 4 plus 2 plus 4 will give us 6, plus 3 will give us 9. That's a 9 that we have here. So do 2 divided by 9 times 6, 9, 23 gives us 1538. 4 divided by 9 times 6923 gives us 3077. 3 divided by 9 times 6923 gives us 2308. Once we get the prorated units for each, then we multiply that by the selling price. The selling price for the footballs, which we have here, was 7. So 7 times 1538 gives us 10,766 as the revenue required for us to break even with the balls. You do the same thing for the baseball, you get 18,462, and the rugby you get 20,772. When you sum those up, you get your total revenue of 50,000. We could also graph multi-product situations to indicate the relationship between cost and revenue and volume. We have a multi-product PV chart which can be produced, which will plot each of the products individually, so allowing their profitability to be compared. The products are also plotted in the order of their CS ratios. Let's look at this example question. So below is a sketch of a multi-product PV chart for lecture example 5. So this is our lecture example 5. So what do the points Y and Z represent? So Y is here and Z is there. So what do these points represent? So point Z, point Y, which is that one there, so break-even revenue if most profitable product made first, in product Z, mount product break-even revenue, Y is the break-even revenue if products are plotted in order of the CS ratio. So basically, when you're plotting a multi-product break-even chart, you want to start with the product which gives you the highest CS ratio. So if you see the CS ratio for the footballs is 57.1, followed by the baseballs, then lastly the rugby. So you want to plot them in that order. So from here to there is the footballs, from there to there is the baseballs, and then lastly from there to there is the baseballs. So that's how you plot a multi-product break-even revenue chart. So Z is the break-even point based on the weighted average unit costs. So once you've plotted that, then you draw another line starting from the first one to the last point. So you draw, so initially you connect the different products and then you draw from the first point to the last point of the product. So that is the 50,000 there on the Z is a break-even point based on the weighted average unit contributions. The Y is a break-even point if you sold based on the individual products, starting with the one with the highest CS ratio. Again, you want to start with the one with the CS ratio because then you reach your break-even quicker with that combination. So this brings us to the end of our topic on cost volume profits analysis. We shall consolidate that knowledge now with questions from the revision kit. Again, I would urge you to go through the video once more, then apply those theories, those formulas in past exam questions. Thank you for listening. We will catch you in the next video.